Hello everyone, I am Sahil, PhD student of IIT Indore. So today I am going to discuss about locus and will demonstrate it using GeoGebra.
So first of all, we will look at the what is definition of locus. What is locus? So in geometry, locus is nothing but a set of all points which satisfies some. In other words, locus is nothing but the path followed by a moving point which satisfies some conditions. For example, if we are walking in a garden or we are following a track, then the path which will be followed by our footsteps is the locus of our feet. In geometry, the curves like lines, circles, parabola, ellipse, etc. are nothing but the locus of one or more points which satisfies some criteria. Okay, so we will use GeoGebra for its demonstration. Okay, so what is a line? A line is nothing but the locus of a point which is equidistant from two given points. Let us look at it using GeoGebra. Okay, first of all, what we will do, we will fix 2 points A and B. Okay, so now what we want to do, we want to collect all those points which are equidistant from these 2 points A and B. For that, what we require a circle. Okay, for that I am drawing a circle around A and B of radius A, where A is what? A is ranging from 0 to 10. With time, my radius will increase according to as my A will increase. Okay, so after that I am trying to intersect two circles, take the intersection points which are C and D, which you can see here. After that, I am going to trace these points C and D. Okay, so remember that C and D are nothing but those points which are equidistant from A and B. So now we want to trace these points C and D. Now we will want to see what these points C and D will trace, which you can see clearly that they are tracing a line, a straight line. So it means any point which is equidistant from two given point will trace a straight line. So now we will go to another example, which is a circle. So now we'll look at what is a circle. A circle is a locus of a point which is at a fixed distance from a given point, and that fixed distance we call it as the radius of the circle. Okay, so now let us take a point A and draw a line segment from A of length 3 say, and now we want to see what this point B, which is the end point of this segment, traces out. So now if we try to trace this point B, we can see that it traces out a circle, which you can see in this video. Okay, so it means what? It means any point which is at a fixed distance from a given point traces out a circle. So ellipse is a locus of a point, sum of whose distances from given 2 points remains constant. Okay, so to demonstrate this, what we require? We require 2 points, say A and B. Also we require a point C, say, such that the sum of whose distances from these 2 points A and B remains constant. So how we will collect those points? What we will do? We will draw a circle, say of radius A, small a, around A. Also, suppose that if we want the constant distance to be 5, what we will do for that? We will draw another circle around B of radius 5 minus A. Now if we intersect these two circles, the intersection point will satisfy the property that these points will give us the constant, the sum of distances will be constant. Okay, so now we will want to trace these 2 points C and D. Again also you can see that the distance DA and DB, if the sum of these two distances is 5. Okay, so now if we try to trace these 2 points C and D, we can easily see that these 2 points C and D are actually tracing out an ellipse, which you can easily see in this video. And the points A and B are nothing but the foci of the ellipse. So now we'll move to the case of parabola. Okay, so parabola is the locus of a point which is equidistant from a given point and a given line. The given point we name as focal point and given line we name as directrix. To demonstrate parabola, we require a point which is a focal point, which we're naming as A, which is 0, 1. So since the focal point is at 0, 1, so the equation of directrix is given by y is equals to minus 1. Okay, so now let us choose a random point, say D, on this line of directrix. Now what we will do, we will draw a perpendicular line passing through this point D. Now join a line segment between A and D. Take a perpendicular bisector of this line segment AD. Wherever this perpendicular bisector will cut the perpendicular line passing through D will give us a point. And this point is satisfying the property that the distance of this point to A and to point D will be same, which you can see, which is 2.18 in our case. Now we'll try to trace this point E. So if we try to trace this point E, it will give us parabola, which you can easily see in this video. Also, the vertex of this parabola is nothing but 0, 0 and focal point is 0, 1 and equation of directrix is y is equals to -1.